Today, windmills use only 2 or 3 blades, allowing over 80% of the wind to pass through without being captured, which makes them about 20% efficient. Their size and design, reminiscent of airplane propellers, create a high-pitched noise that increases as they build larger and larger windmills. Take into account that the average diameter of wind turbines are as long as a football field. The design also makes it difficult to become aligned with the wind flow and requires extra equipment and power to rotate in order to come into contact with the wind. Compounding these issues, the systems can only operate in a small range from about 12 to 30 miles per hour. In higher winds, the blades create a racking motion, causing deformities in the blade, which leads to shutdowns and, at times, disasters. In direct contrast, the Windsail uses a patented 4-blade system modeled after sails, the oldest wind technology in the world. This design captures over 80% of the wind and is over 90% efficient. The reason for such high efficiency is the 3-dimensional design of our blades. As the wind flows into our system, it first contacts our aerodynamic hub, shaped to increase airflow to our blades, which increases rotation and energy creation. An added benefit of our 3-dimensional design is that if the wind changes direction, we change direction. And even better, the Windsail is completely silent in low and high winds. Unlike systems of today, the Windsail operates from a range of 3 to 50 plus mile-an-hour winds, and the faster the wind blows, the more rigid the blades become, allowing them to operate more effectively. The Windsail produces 4 to 5 times the amount of power of other contemporary units of the same size. And do you want to know our secret? More captured wind equals more power. The second major flaw of current wind turbines is the materials used to create the blades. They are composed of many layers of graphite composite and or fiberglass, and these materials are prone to cracking in high wind and made brittle by the ozone. The adhesives used to glue the layers together are extremely toxic and hazardous to dispose of. As temperature changes occur, the material can lose structural integrity, causing the blades to come apart. And due to these complexities of the materials involved, the manufacturing process to complete one blade takes close to a month. The Windsail has solved all these problems as well. By using polyurethane technology, we created a stronger monolithic blade, which means it's all in one piece. The materials used are completely safe, and the blades are 100% recyclable. The blades are so durable, in fact, they can operate in temperature ranges from negative 100 degrees to 400 degrees Fahrenheit without losing structural integrity. With a design for our manufacturing equipment, we estimate we can make a blade for the 12 or 18-foot system in 3 to 5 minutes. On top of that, the effect wind turbines have on the bird population is dramatic. Environmentalists estimate that millions of birds and bats are killed each year by either running into the blades or having the oxygen sucked away from them as they fly near, causing their lungs to collapse and fail. The small profile of windmill blades make it appear birds can fly through without being harmed. Whereas the Windsail creates a full profile that allows birds and bats to see and detect, so they won't attempt to fly through. If they do happen to go through the blades, they'll fly out with the airflow at a 45-degree angle. Windsail is the solution for harnessing the power of the wind. Our prototype is a 6-foot system, which we have been operating all around the world, including Belgium, Canada, South Korea, Mexico, and here in Vegas. Another application we are testing is the 6-foot prototype for energy reclamation. We mounted a prototype over an air conditioning unit at the Silverton Casino in Las Vegas. This site reclaims over 4 times the amount of energy produced by the best of today's contemporary models.
This is why we have come to the Kickstarter Nation. We have tested the prototype 6-foot wind turbine for 3 years. With your help, we can increase the sizes to 12-foot and 18-foot diameter systems. These systems will be capable to power neighborhoods, villages, industrial buildings, and can be used for wind farms. Help us replace the inefficiencies of today with the wind turbines of tomorrow. Thank you.